Okay, so this is just review. This is not going to be a piece that you have to do in your assignment. The second piece is. So we go back to example 2. It says, the definition. Use the definition of continuity and the properties of limits to show that the function is continuous at the given number. So let's just think about continuity in general, okay? So there are 3 parts to make sure that continuity exists. What's the first condition? F of A exists, right? What's the second one? The limit as x goes to a of the function exists. And what's the third one? The limit as x goes to a of the function must be equal to f of a. Those must be the same. So let's just think about them. This will help you remember. By the way, you have to know these 3 for the test. You have to know them in order. Okay, memorize it. Got it? Locked in? Just it's easier if you just like screenshot it in your brain. Then you'll never forget it. Do you guys have that app? Got that? Download that app, screenshot it in your brain, you'll be good to go. Okay? All right. So we try the first one, okay? I want to show that this is continuous. So we have to first show that f of a exists. So let's plug in 2. What is f of 2? It's 1. What does that graph look like? Tell me something about it. Something like that? Okay. As x approaches 2, does the output approach 2? Does it make sense that it would be the same from the left as it is from the right? Yeah, so the second one is the limit as x goes to 2 of the function is also equal to 2. Oh, I'm sorry. Is equal to 1, excuse me, right? Are those the same? Yes, they are. So if I plug in 2, 2 times 2 is 4, minus 3 is 1. We good? And the limit is also going to be 1. You can see it's the same from the left as it is from the right. Are those the same? Yeah, so the third statement is then the limit as x goes to 2 of the function is equal to f of 2. And in both cases, they are what? They are 1. True or false? This function is continuous for all real numbers. False. Where is it discontinuous? 2. At 2. Is it telling us that it's continuous at 2? It's saying it's continuous at 1. Let's try that. What is f of 1? Negative 1. So we've determined that it satisfies the first requirement. Let's look at the second requirement by looking at the graph. Somebody tell me something about that graph. Good, it's 2 units to the right. Patty? We got boom and boom. Okay? Like that? So the limit as x approaches, so I got number 2. The limit as x approaches what? 1 of the function. Let's look at as x approaches 1. Should it be a positive value or a negative value? Negative. And it's going to be the same thing, isn't it? Like you can tell, it's continuous there, isn't it? It's going to be negative 1. Are those the same? Is negative 1 the same as negative 1? Yes. So therefore, the limit as x goes to 1 of the function is equal to the function value, which is negative 1. So we've determined continuity. Yes. Okay, so I'm going to approach 1. See that? So first of all, do you agree that f of 1 is negative 1? How do I find that? So I take 1 and I plug it in. Okay, so watch. Do you agree that f of 1 is negative 1? Okay, so I know that that's a point on the graph, right? So you know that that's a point on the graph. So if I'm approaching from the left, I'm approaching negative 1. And if I'm approaching from the right, I'm approaching negative 1. So we know that the limit's negative 1. The top one? The top doesn't matter because I'm only looking at the value of 1. I'm not approaching 2. If you were approaching 2, we would say negative infinity, positive infinity does not exist. But we're approaching 1. That's right here. So a lot of people will look at this graph and they're like, oh, discontinuous. Discontinuous at 2, but not at 1. We're trying to show it's continuous at 1, and we have shown that. Okay? Now, I'm not going to have a problem on the test or your homework where you demonstrate continuity. I did that to kind of review and prime your brains for today. So we got 2 questions to go over, and we're going to give you some time to work. We have our last lesson for the unit tomorrow. Okay? We already explained why these were discontinuous, but now what we want to do is we want to fill the Okay? Very good. Now we are going to fill the discontinuity. Okay? True or false? This function is discontinuous at -3. True. So I'm going to show you what the graph looks like. X plus 3 times x minus 3 over x plus 3. So what cancels? So does everybody see that this graph wants to look like x minus 3? That's what it wants to look like. Because there's a hole. For what value? -3. If I look at my graphing calculator, which I'll take out, these 2 examples take just a little bit of time, which is why I tried to leave it today. I thought that it would just confuse us yesterday if I would have pushed through it. So I'm going to go ahead, I'm going to go to my y equals, and I've got x squared minus what? Minus 9 divided by the quantity x plus 3. Okay, I'm going to zoom 6, and whoop, looks like I took my axes off, didn't I? Remember that yesterday? Remember that fun little game we played? All right, so I'm going to go to Format, and I'm going to turn my axes on, and I'm going to go back to my graph. And does that look like the graph of x minus 3? But we know that there's a hole that exists, right? And if I zoom as a decimal, maybe I'll actually see that spot. Can't quite see it, so I'll zoom out within that decimal zoom, and maybe now we will see where the hole exists. Come on, Kevin. Oh, it skipped over the 3 spot there. See how it just skipped over it? I wonder what I should... This has never happened to me before. What should I do? Try again. Zoom 6.
Probably just give up. That's what I would do. Jesus is always the answer. But I'm I don't get class song. I don't see this. Oh yeah, real like agree. Probably thought. Oh, maybe I'd get best hair. Not anymore. Not every 7 days. Just.
There it is. Okay, you see it?
Yeah.
Okay, so keep trying. Yay, thank you. All right, so we've got our graph. And we know that the graph is shifted down 3 units, okay? And then when we get to an x value of -3, we have an open circle. So this is where the confusion happens, and I really want people to focus in and ask a question if you need to, okay? Does everybody see how I know that the graph looks like x minus 3? Okay? Does everybody see how I know that it's at -3 that I'm going to have a hole? Now I'm going to show you how you figure out the y value. I know that the y value is -6. I know that that's where that happens. Anybody know? If you simply plug your -3 into that, what's -3 minus 3? Do you see it? So the directions are as follows. The following functions have a removable discontinuity. That's the removable discontinuity. fill the discontinuity by writing a piecewise function. So here's what it's saying. We have f of x is equal to that guy, x squared minus 9 over x plus 3. This thing is continuous for all x values except what? So I say for x not equal to negative 3. So we want that function for any value other than negative 3. Everybody okay with that so far? So, how about when x is negative 3? What should the y value be to fill the circle? Negative 6. That fills the discontinuity.
So like if there was.
Yeah. So like if we wanted to fill that discontinuity, what would the value have to be? That guy. Yeah. So we'll do the second one without a graph, and this is the last one, and hopefully this will kind of come together for you, okay? So, this is discontinuous for what value? 1. Everybody agree it's discontinuous for 1? So I'll write my piecewise function. F of x is equal to, that was really bad. That was bad. We're going to try that again. Oh, g of x. G of x is equal to x cubed minus 1 over x minus 1 for x what? Not equal to, for x not equal to 1. Everybody agreed? For x not equal to 1. But when x is equal to 1, we have to figure out what y value would fill that spot. You okay? So in order to figure that out, we have to remove the discontinuity. Do people see how we could factor this to get that to go away? Do you remember how to factor the difference of cubes? Avery points up to the board right there. There it is. So x cubed minus 1 over x minus 1 does factor. Factors to a binomial and a trinomial. And then a binomial on the bottom of x minus 1, obviously. So what do you cube to get x cubed? X. And what do you cube to get 1? 1. Plus or minus? Minus. Everybody see that? Now, square the front. X squared. Square the back. 1. Multiply the two together. X. The end is always positive. This is opposite whatever that is. Okay, so I factored it correctly. What can I now do? Great, I got rid of the discontinuity. So in order to figure out what that should be, I take that and plug it in. When we plug it in, 1 squared is 1 plus 1 plus 1, 3. That filled the discontinuity. Avery, is there a chance that you may not remember how to factor the sum or difference of cubes? I was in your boat as well when I was your age. And can I show you how I figured out I never have to remember that formula? Okay. Anybody else want to see how I never had to remember that? Never had to remember that. Want to see it? Folks, you're just taking x cubed minus 1 and you're dividing by x minus 1, right? Okay, we're just dividing a polynomial, right? So I take the solution of that, which is 1, I put it in the box. And I take that, which is 1, 0, 0, negative 1. Everybody remembers how to use synthetic division, don't you? Watch, because I tell you, I like this because it works for me every time. I don't have to remember any of that. You bring down the 1, and then you multiply. 1 times 1 is 1. Add 1. Multiply. Add, or 1. Multiply. Add.
0.
So this is x squared plus x plus 1, which is exactly what I have right there, isn't it? No, I just quick write it down on a sheet of paper. So there's 0x squared and there's 0x.
Okay.
So I never have to remember 7 different cubes. I could use synthetic division all the time, basically. But you do you. 2x cubed? Right here, 2, 3, 4. So it'll be 2x squared plus 3x plus 4. You like that? Okay, last lesson is tomorrow. The nice thing is you already know how to do tomorrow's lesson. You just don't know that you already know how to do it. So we'll end with that. When you get back on Monday, it'll be a time to work on your study guide, and then Wednesday you will have your test. So it is your time to work. Go.